Why do bees make honey? The real reason will surprise you. Honey seems almost too perfect to belong to the natural world. It's sweet, golden, lasts for years without spoiling, and has been treasured by humans for thousands of years. It almost feels as if bees created it especially for us. But here's the strange part. From a bee's point of view, humans don't matter at all. Every drop of honey was made for a completely different reason. And once you discover what that reason is, honey stops looking like a delicious treat and starts looking like one of evolution's most remarkable survival inventions. The mystery begins with flowers. Flowers already offer nectar, a sugary liquid that bees eagerly collect. If nectar is already packed with energy, why spend countless hours turning it into something else? Why not simply store the nectar exactly as it is? At first glance, that seems like the obvious solution. But nature has a problem with obvious solutions. Fresh flower nectar is mostly water. Depending on the flower, it can contain around 70 to 80% water. Imagine filling your pantry with fresh fruit juice instead of canned food. It might taste wonderful today, but leave it sitting for a while, and bacteria, yeast, and mold quickly move in. Nectar spoils far too easily to serve as a long-term food supply. For centuries, people watched bees carrying nectar into their hives, but had little idea what happened next. Some assumed honey simply collected inside the hive on its own. Others believed bees somehow transformed flowers into sweetness by magic. The truth turned out to be much more impressive. Honey isn't collected, it's carefully manufactured, and the factory begins inside a single worker bee. When a worker bee lands on a flower, it drinks nectar through its long tongue. But instead of sending that nectar into its digestive stomach, it stores it in a separate chamber called the honey stomach, sometimes called the crop. Think of it as a tiny reusable storage tank built specifically for transporting nectar. The nectar doesn't just sit there. Even before the bee flies home, chemistry has already begun. Inside the honey stomach, special enzymes start breaking down the nectar's sugars. One of the most important is invertase, which splits sucrose into simpler sugars called glucose and fructose. That might sound like a small chemical change, but it makes the future honey more stable and easier for bees to use as food. So by the time the bee reaches the hive, the nectar is already becoming something entirely different. But it's still far too watery. Now the hive itself takes over. A returning worker doesn't simply pour nectar into a honeycomb cell. Instead, she passes it to another worker. That bee may pass it to another. With each transfer, tiny amounts of water evaporate, and more enzymes continue working. It's a bit like an assembly line where every worker performs one small step before handing the product to the next. Thousands of bees repeat this process over and over, all without anyone directing them. Then comes one of the colony's most extraordinary engineering tricks. Worker bees gather near the honeycomb and rapidly beat their wings. They're not trying to fly, they're creating airflow through the hive. The moving air steadily pulls water out of the processed nectar, much like a gentle breeze dries wet clothes hanging outside. Hour after hour, the liquid becomes thicker, sweeter, more concentrated. Eventually, the water content falls to only about 17 or 18%. That single change transforms everything. Most bacteria and fungi need plenty of water to grow. Honey contains so little available water and is naturally acidic enough that most microbes simply cannot survive in it. Instead of using preservatives or refrigeration, bees rely on chemistry and careful drying to create a food that can remain stable for incredibly long periods.
Once the honey reaches the right consistency, the bees seal each honeycomb cell with a thin cap of beeswax. Only then is the job complete. What began as fragile flower nectar has become one of nature's most effective methods of preserving food. But why go through so much effort? The answer appears only when winter arrives. Many insects escape cold weather by laying eggs or entering a dormant state until spring. Honeybees do something very different. The colony stays alive all winter. The queen remains protected, while thousands of workers gather into a dense cluster that constantly generates heat by vibrating their flight muscles. Staying warm, it requires enormous amounts of energy. Yet outside the hive, flowers have disappeared. Without stored food, the colony would simply starve. That's why honey exists. It isn't dessert, it's survival. Throughout the cold months, bees gradually consume the honey they spent spring and summer producing. Every spoonful represents sunshine captured by flowers months earlier, then preserved until the landscape becomes barren. This also explains why bees often produce far more than they immediately need. A generous reserve of food provides insurance against long winters, poor flowering seasons, bad weather, or unexpected demands as the colony grows. Scientists are still studying exactly how colonies balance collecting nectar with gathering pollen under changing environmental conditions, but having a substantial reserve clearly improves the colony's chances of surviving uncertain times. And here's another surprise. Not every bee makes honey. There are more than 20,000 known bee species, and most are solitary insects. They build nests, gather food for their young, and never create large honey stores. The elaborate process of producing honey is characteristic of honeybees and a few closely related social bees that live together year-round. That social lifestyle changed everything. Because thousands of individuals cooperate as if they were parts of one larger organism, they can accomplish tasks that would be impossible alone. Some collect nectar, others process it, others fan their wings, others build wax combs. No bee understands the entire plan, yet together they create a system of chemistry, architecture, climate control, and teamwork that has evolved over millions of years. Even the honeycomb reflects that efficiency. Its familiar hexagonal pattern stores enormous amounts of honey while using surprisingly little wax. Every part of the hive helps solve the same challenge, preserving as much energy as possible with as little waste as possible. Humans eventually discovered this extraordinary food and learned to harvest it. We've enjoyed its sweetness for thousands of years, used it in cooking, and admired the fact that it can remain edible for astonishingly long periods. But from the bees' perspective, we're simply lucky visitors. Honey was never meant to be our reward. It was designed by evolution for theirs. There's one final detail that makes this story even more remarkable. A single worker bee produces only about 1/12 of a teaspoon of honey during her entire lifetime. Every jar represents the combined work of countless flights, millions of flowers, and the coordinated efforts of an entire colony. So the next time you see a spoonful of honey glistening in the light, you're not just looking at something sweet. You're looking at sunlight gathered by flowers, transformed by invisible chemistry, protected by careful engineering, and stored through extraordinary cooperation, all so a tiny colony of insects can survive a season when the world outside has nothing left to give.